volume of prisms. The formulae that I'll give you here are given to you in your textbook, so you're welcome not to write them down. Just want to look at how we get the formulae. A prism is a three-dimensional shape that has the same shape on the front and on the back. So this has a rectangle at the front and a rectangle at the back. This one has a square at the front and a square at the back. This one's got a triangle at the front and at the back, and a circle on the front and a circle at the back. And the parts of the prism that you need to know for its volume are the area of that face that's the same on the front and the back, and the height or the length of the prism, which is the distance between those two faces. So from the circle back to the back circle, from the triangle back to the one at the back, from this square back to one at the back, and back there. The length or the height of a prism is the distance between its two identical faces. And the volume formula that will work for any prism is the area of what we call its cross-sectional face, the thing that's identical on the front and back, times the height, that is the distance between those two faces. But a lot of these have little formulae that will work as well. So for any rectangular prism, the area of the front would be width times height in this case, times the length of the prism. So it's just width times height times length, or length times width times height. So that's our formula that will always work just for a rectangular prism. Just get the 3 dimensions and multiply them. A cube is exactly the same really. It's just going to be the area of this square is length times the length of the prism. So the volume of a cube is length cubed. For any other shape, we're doing volume equals area times the height or the length of that prism, the distance from the front face to the back face, the two identical ones. So basing this on volume equals area times height, the area of the triangle is base times the height of the triangle divided by 2, or half base times height of the triangle, and then that's why we like to call it the length of the triangular prism, because that's the distance between the two triangles. So please do remember, for a triangular prism, that height is the height of the triangle, because you're getting the area of the triangle and that needs the height of the triangle. And I'll just put a little box around that one. For a cylinder, it's still volume equals area of the circle times the height of the prism, but the area of the circle is pi r squared, and then we times that by height. So that will work for a cylinder. For all the other prisms, such as if they had a different shape, volume equals area times the height of the prism is going to work. So a couple of examples. So to find the volume of a rectangular prism, volume equals length times width times height. 6 times 12 times 4, which is 288, and we're measuring volume, 3-dimensional space, so we are in centimeters cubed. Formula, working, answer with units every single time. A rather badly drawn cylinder. The formula for a cylinder is pi r squared times height. So the radius is 5, this will be pi times 5 squared times 25. Get our calculators out for this one. Pi times 5 squared times 25. Oh, scientific calculator, just hit that button there. Oops. And we are in meters cubed. So formula, working, answer, saying what it is that we're finding each time. two more examples that might get a little harder at times. A triangular prism. So volume equals half times base times height, the area of the triangle, times the length of the prism. Remembering that this height is going to be the height of the triangle to get the area of a triangle. That will be a half times 3 times 4 times 6. So I've got 6 times 6 is 36, and we're in meters cubed. So just be very careful with triangular prisms. Now this one we don't have a formula for, so we have to go back to volume equals area times height. And you identify the shape that's the same on two sides, and it's this trapezium. So you're going to have to substitute in the trapezium area formula, which is half a plus b. Now, that's times height in the area formula, which is really annoying. That's the area, and then it's times the height of the prism. So remember, you can say length for the height of the prism instead. This one is the length of the prism, the distance between the two identical faces, and the height is part of the area formula for a trapezium, so that's 6. If you preferred, you could separately find the area of the trapezium and then write the volume formula and just substitute the area in rather than getting those heights confused. But we can do this. That will be half times. A and B are the parallel sides of a trapezium, so that will be 10 plus 15 times the height of the trapezium, which is 6. That's our area, times the length of the prism, which is 25. And so simplifying there, I've got 10 plus 15, that's 25, a half of that. Sorry, you might prefer this way, mightn't you? A half, 0.5 obviously, times 25, then times 6, then times 25. So we're just working our way along because this is all multiplying. Half times 25 times 6 times 25, I've got 1875 centimeters cubed. That's our volume. Now, if you would prefer on this one, if you're happy with that, I'd stop there, go do your work. If you would prefer, we know I need volume as area times height, but it gets a little confusing, so you can just do area is half of a plus b times height. That's half times 10 plus 15 times 6, which works out as 75 centimeters squared. And then give the volume equals area times height. That's 75 times the height of the prism, which is 25, which gets us the same answer in centimeters cubed, but can just be easier to think about. Area first, then the area times the height or the length of the prism. Either of these methods are fine. It's whichever one you find easiest to do the working for without getting those heights mixed up.